I want to run through. Pretty sure you all did your homework assignment. Rather than nitpicking stuff, we'll just put the points in for you if you were here. What page was it, or what section?
5.4.
5.4. All right, I'm trying to get there, maybe. So we do have our test on Monday, which is great. We moved it for you. I'm really mad that I didn't give it yesterday, because if I gave it yesterday, we could have I could have had it graded in the grade book, and we could have moved on. All right. Hey. Yeah, will you flip the light switch off on your way out? All right. Any questions from the 5.4? Thank you. Worksheet. Yeah. 11A and B. 11A and B. Shh.
Can you do number 1, 2?
Okay, well, let me do these first, and then I'll get to your question. 11A and B. Okay, this is what we're given on these two. It says list all the sides of each triangle from smallest to largest. So the first thing to do is find what your other angle would be. So that would have to be 40. The reason it's 40 is because 40 plus 50 plus 90 is 180. And then the opposite sides of the angle. So XY is the largest, because it's opposite of the 90-degree angle. Does that make sense? And then opposite of the 50 is our middle, because 50 is larger than 40. And then opposite of the 40 is ZY, which is the smallest. That make sense? Then for this one, we're not given the 90-degree angle, but we know those two, that's 100, so this has to be 80 degrees. So the side opposite of the 80 degrees has to be the largest. And then BC is the middle. And then AC. Done. Does that make sense? Cool. Johnny, you wanted number 1?
Yes.
One what?
E.
1E?
Johnny's not paying
Can you just do 1?
I know he's not.
Johnny's
1E. Make a conjecture about DE. Well, I guess I'd have to do the whole thing, right? Construct the midpoints of AC and AB. Okay. Problem number 1. All right. Can I do it without using the construction tools? Construct the midpoints of AC. So AC, here's our midpoint. And we'll label that D. I did the construction. You all see that? And then AB, the midpoint of AB, we're going to label that E. Is that all right so far? Draw segment DE. Okay. What is DE called? The mid-segment? Right? Measure angle ADE. So I'm measuring this angle. Did someone get a number for me roughly?
Sorry, I give you food. Thank me.
So measure of ADE, measure of ACB. I have no idea what they are. Less than 90, greater than 0. But I will tell you they're exactly equal to each other. Is that right? So I know this angle is equal to this angle. I don't know what they are. You can measure them with your protractor. 70-ish? 75-ish? All right, so a number that's thrown about 75 degrees. Okay? I don't know. I didn't measure it. Measure DE and measure BC. So how long is BC, how long is DE? I know DE has to be half of it. Do we have a measurement? Am I the only one here? One. I just went down all of the questions.
Oh, I see it.
How much?
Oh, wait, which one?
ED or BC? I just want to measure them.
Oh, 3 and 6.
So that's 3 and that's 6. Okay, I'll take that. Measure segment DE and BC. So now that's 1D. So 1E, make a conjecture about DE. DE is half the distance of BC. DE happens to also be parallel to it. I don't know. That's about all I can say. Cool. Johnny, does that work for you?
Yeah.
Yes, ma'am.
Are you listening, Johnny?
So, can you go over how to find the range for 13?
Which one?
13.
13. Oh, perfect. Yeah. Number 13, we have A and B, so I'll try to draw these as best we can. Okay. Here we go. So these are asking us on number 13, find the range of the possible values for x. Okay? So if I just look at this top triangle here, the smallest value x has got to be greater than 4. And the reason I say that is because 4 plus 6 has to be bigger than 10. So if I'm greater than 4, that would work. But then we have to assume that x could also be the largest side as far as this goes.
Smaller
So-
than 12.
Smaller, wait. I'm just looking at the top triangle though.
Smaller than 16.
Smaller than 16.
I did that wrong.
Okay? So that deals with our top triangle. Is everyone okay with that so far? Okay, so then we have that second triangle to deal with. So let's take a look at what this bottom triangle will do. So if we're looking at the bottom triangle, x has to be greater than 8 because 6 plus 8 has to be big. It has to be bigger than 14, right? And then it also has to be less than 20. So now let's figure out what would fall under our parameters. Okay? So will 4, 5, 6, or 7 work according to that? So we know we have to be at least that. Good? And then will 17, 18, 19, 20 work with respect to the other? So we have to have our values greater than 8 and less than 16. If you wanted to get all fancy and put it together, in the algebraic method, you could do it like this. I would probably take either answer and be fine with it. Okay? And then number 13, the other one, I need to find this third angle. Let's see, that's going to be 110, so that should be a 70-degree angle. Agree? Okay, so what can you tell me about x right now? What would it have? It's the smallest side, right? So if that's the smallest side, that means that x has to be greater than 6, and we don't do the other bound. Okay? Has to be greater than 6. We can't go above 16, so it also has to be, all right, excuse me, it can't go above 26, but I have to be careful that it doesn't get above 10. So values that would work, it also would have to be, x would have to be less than 10. And the reason why we have to say that is because if that was 10 and 10, opposite of the 30 being 10 and opposite of the 70 being 10, that wouldn't make sense. Now, it doesn't really make sense that this could be 9.99999 repeating forever. It doesn't really make sense. But later in math, you will come across, like, you can't use Pythagorean theorem on this, right? Pythagorean theorem, because we don't have a 90-degree angle. There's something called the law of sines or the law of cosines that work with triangles that don't have that in there. Okay? But we're not there yet. Those are really cool things that work. You had a question.
Are we doing sines and cosines this year?
Later.
3.
Number 3. Just for those of you that have the curiosity factor, are we going to do sines and cosines and tangents? So you guys might have all seen this. So you ever see that?
You spell car wrong.
SOHCAHTOA. SOHCAHTOA is what they use, and they say, oh, what did the Indian chief say to this squaw when he stubbed his toe? And she said SOHCAHTOA. And then we came back with saying, you know, it's disrespectful to the Native Americans to use that. So we make fun of a different social group in order for us to remember this. So that's SOHCAHTOA. So some old hippie caught another hippie tripping on acid is how we remember it.
Oh my God. Wait, can you repeat that one more time?
Some old hippie caught another hippie tripping on acid. That's how
Nice.
that's how you remember that. But,
Oh my gosh.
so, just because man's making fun of hippies. Yeah, I guess I am.
Some old hippie caught another hippie.
All right, it says that EB is the mid-segment of the big triangle ACD. EB, so they tell us that EB is this, and CD is this. Find CD. Okay, so what can you tell me about the mid-segment EB in relationship to side segment CD? Yeah.
It's half.
Okay, so
Parallel.
this is half of this, or this. If I double this, I get that. So whichever way you want to go. So if you double this, or you half of this and set them equal to each other, it's going to work. It's one or the other. I can't tell you which one to pick. It's your choice. So if I half this, if I half this, what do I get?
3x minus 1.
3x minus 1. Everyone go with that? And that will be equal to the relationship 2x plus 6. All it is distribute over the parentheses. Still with me? Subtract 2x, I get x. Add 1, x equals 7. If x is equal to 7, I forgot what we were trying to find.
Is that always right?
Yes.
Neat.
CD. Oh, we want to know what this length is. So that's 6 times 7, 42. So that's 40. Cool. If that's 40, that would mean this would have to be 20. Sweet. Yeah. 9C. All right. Those of you who can't remember the hippie thing, it's recorded. It's at roughly 12 minutes in. Which were we doing? 9 what? 9C.
You want an onion Eugene? Afterwards?
Don't give Eugene an onion.
You know what
Did you
happens?
say that last time? You're just onion interested.
All right. All right. Things that we might need to know. 9C. What does it say? Determine the possible values for x in each. Okay. So we know that 2x minus 3 has got to be greater than 4. Why is that? Because 5 plus 4 is 9. So this side has to be a little bit bigger than 9. So that's why it's greater than it. So if I solve this, I get 2x is greater than 7. So x is greater than 7 over 2. And then we could also assume this could be our largest side. So then we have to know that 2x minus 3 has to be less than 9 plus 5, which is 14. Solve that. So 2x is less than 17. X is less than 17 over 2. 8.8 and a half. Something like that. Yeah.
On the test, would you want us to like bring it all the way down to x is less than 12, or could we just leave it at 2x minus 3 is greater than
Oh, I'd want you to actually solve for what x would have to be. Did I answer that whole question? I didn't read the whole thing. 9. Find the possible values of x. So it has to be bigger than 7 halves, which is 3.5, and less than 17 halves, which is 8.5. Yeah.
How many days are we going to just review for the final?
Yes.
Yes. Thank you.
7. EB mid segment. Correct. Because Don gets my sense of humor.
Hey, Mr. Stroud,
Yeah, buddy.
you see this piece of lettuce? Let us go over number 7. Oh my goodness!
Leave. Leave now.
Like, honestly,
Leave. Leave.
Why don't you get like a tree and get out? What movie? Anybody?
Wait, what is that?
No,
What?
You guys don't know that?
Why don't you make like a tree and get out? Back to the Future.
That's the bully, right?
Yeah, Biff.
Oh, that was good.
Was that the first one or second one?
For the third one?
I think he said it in all 3.
That doesn't make sense to me.
I know. It's why don't you make like a tree and leave?
It happens in like
But- But he says why don't you make like a tree and get out because he's dumb.
I get it.
All right. Shh. So EB is the mid segment of DC. So this has to be half of that. Shh. Hush. Was that the whole thing you wanted me to do?
Yeah.
So A, we know that EB is 1/3 Y, and we know that CD is Y minus 4. Okay. So if that were the case, so 1/3 and then 4. So I can either double this to equal that, or I can half that to equal that. I don't care. So double this, I get 2/3 y is equal to y minus 4. Let's multiply everything by 3 to clear the denominator. Subtract 3y, so I get negative y equals negative 12. So y is equal to 12. There's your answer for A. Your answer for B, they tell you that. Oh, wait. Wait, wait a minute.
Oh, wait, I got Y.
That's B. I did B. I just did B. I skipped A. I don't know why. Shh. I think it's too many people are talking. So AE, they tell us is 1/2 x plus 4. And they tell us that ED is x. So if that's the mid segment, what does it tell you about these two segments? They're equal to each other. Right. Good going, Sawyer.
You had a really high voice.
Yeah, I was about to say that, but then
How rude.
X equals 8. Those are equal to each other. And then, if measure of angle A is 30, this is for C. Measure of ABE is 40. Find ADF. So they want us to find this angle. Ooh, okay. So if that's 30 and that's 40, that's 70. So that means that has to be 110. So if that's 110, this one has to be 110. So those are parallel and those are corresponding angles. So that means that this one would have to be 70 because if I add the two together, they have to equal 180. And that is about all I got for you right now. Good? No applause, just throw money or candy. All right. We good? Pretty sure y'all did that. Therefore, points are going in for y'all today. Okay? Giddy up. All right. Yeah, this is just some review. And then we're going to do Don's favorite thing. We're going to play hide and seek.
Kahoot?
Yes! Oh, Kahoot. Yeah, that's right.
I didn't see.
Wait, look at it.
Hide and seek's
Wasn't
fun.
Andrew like what?
You never played?
Yeah, dude. He knocked me
Is that you?
4 times in the head.
Eugene's never played hide and seek, everybody.
Yeah.
No, I didn't.
Eugene, go hide. We'll try and find you.
Not it.
You're gonna take us forever.
I told you. Eugene, I'm just kidding. Eugene's trying to hide.
Dude, he's a boxer.
Wait, look here.
If he never comes back, I'll be in trouble. He'll show up on Monday. Eugene's still not here. Oh, he's still hiding.
We'll find him lying under the desk. Wait, Mr. Stewart, is this gonna be? Are you kidding me? Prove chapter 5. Really? Oh. No.
All right, let's run through this. Just kind of a good review. Good review, guys, in back.
I just landed on the cap.
Oh, whatever.
I know, I swear, and then Devin kicked it. You're an inconsiderate.
Sir, give me a break. I'm just like dying.
No one saw that. I just landed on the cap. Thank you. I just landed on the cap.
All right. Let's walk through this proof. So our givens, I'm going to mark off what we know as far as our givens rather than listing them. If you want to list them, great. All right. Yes, you do have to list them on the test. So it says angle DAE is congruent to DEA. So this is congruent to this. So is there anything I can state after that because of those being equal? It's an isosceles triangle. Okay, so because I can label that, that would allow me to state that angle ADE, triangle ADE, is isosceles. If I could spell isosceles. Man, that says isosceles. Can you guys read it?
Yeah.
If not, let's just. All right, and the reason we can state that is we go from here to this. Totally works. All right. Does that help me with anything now that we know that this and this are equal? I mean, theoretically, we have a side and an angle. We need a third side for a triangle or another angle, right? We do have reflexive. Let's see what more are proofs. So then they tell us that CA, C to A, this here, is congruent to this here.
Triangle CAE is isosceles.
And we're, oh, I like it.
Oh, sorry.
So this is what we're trying to prove, right? So if we said, oh, that'll work. That'll work. So then we could go ahead and state that triangle ACE is isosceles. And that's going to be segments to angles. Okay? And if we know that, then I could go ahead and state that BC is congruent to itself, and that's our favorite. No one ever seems to forget. So this is now reflexive. So I have, so we know this as well. Well, angle side side, which doesn't work for us. Okay. That's not going to work for us yet. Huh. Can't say side side angle because that's the same thing as angle side side. All right. I think what we could go to is we probably didn't need this right here. This is not that important. Okay? But I think what we could get to state is that because we know this and this are congruent, and this are congruent, meaning they're coming from an external point to a side, you have equals. So that would mean that BD is the perpendicular bisector of AE. And that's the reason that we could state that is that's the two congruent or two different congruent segments.
Can I get an extra sheet?
Yeah, right there on top. Thanks. And then if you know that, if you can say that, then you could go ahead and state that BA is congruent to BE, and this is definition of perpendicular bisector. Okay? Or you could say definition of bisector, that would work as well. Yeah.
What do you mean by two different congruent sides? Is that like AD and BD?
So, yeah, so I have this and this are congruent. That's one. So that's not going to tell me that it's a perpendicular bisector. But then coming from the same exact point, I have another segment coming to the same exact line, just in a different location, and that happens to be congruent as well. That's why you can say that's the perpendicular bisector, and we can move off of that. Yeah.
Could you have just said that triangle ABC and BC were congruent?
I couldn't get to ABC and EBC because I had only angle side side. And that's what I was trying to go to. I wanted to try and state that. And I thought maybe it would because then it would be CPCTC. But we couldn't state it because angle side side is not going to make it work.
Oh, okay.
But now at this point, if this is the perpendicular bisector, at that one, you could have gone to here and here, which would have given you a hypotenuse leg, which would say they were congruent. Then you go to the CPCTC. That totally would have worked. But I couldn't originally state it because I without this, I don't know I have a 90-degree angle. Yeah.
I still don't understand the two different.
Okay. Let's try and do this. This is how the rule works. Okay. So first thing, if I were to state this and this, if those were givens or told to us somehow, or we were able to prove it, we could easily get to this because it's an isosceles triangle as a whole, right? So then other things we're looking at on there, and this is kind of a bad representation because we do have that shared side. So this is going to allow us to do that's not this. So then if we were to say this is reflexive, we can't state those two triangles are congruent because we have angle side side. Okay, but if I knew or was able to prove that I had this, meaning that and that are congruent, so I have two different sets of congruent sides to the exact same point. So this point here leads to the same line. This point here leads to the same line where you have those congruent segments. That tells us at that point that right here, that and that are perpendicular bisectors of each other. So that would mean that that is congruent to that. That creates 90-degree angle. Does that make sense?
Yeah.
That's the rule we're doing. So it's just kind of like two different sets of congruent sets. There's not really, I guess there would be like theorem 5.4 would be where we were at. But if you were just to state something like, we have two congruent sets of sides, congruent to two other sets of congruent sides. Somehow shorten that however you need to. I mean, I'm not looking for the full sentences.
Okay.
But that's why that works. And then all of a sudden that starts doing this magical thing where we have all of these triangles congruent, which is what we want. Any other questions on the proof? Does that make sense? All right. Let's go to number 2A. We had worked on some of these similar before. Okay, so we want to find all the possible values of x up here. Okay? So the side that's 2x minus 1, do we know that's the longest side or the shortest side or the middle side? Do we have any information to tell us that? No. So first off, we have to assume maybe this could be the shortest side. It would be the shortest side, meaning if this segment was equal to 3, because 10 plus 3 or something just a smidge bigger than 3. So I can say, well, 2x minus 1 has to be a little bit bigger than 3. Okay, so then you go and solve this. And you know that x has to be greater than 2. That's our first limit. And that's just saying that has to be the shortest side. Do I care if it could be the middle side? It's not going to help us right now, but we just need to find that it's either the shortest side or it's the largest side. Okay? So is 2x minus 1 the largest side? What does it have to be less than if it was?
23.
23. Add 1. Divide by 2.
12.
So our region in which that side can be for this triangle to exist, not telling us if it's the longest versus the shortest side, it's just one of the three sides. So as long as that side is bigger than 2 and smaller than 12, we can create a triangle. Yeah. Greater than what? Okay, greater than the 3. Oh, so this plus this has to be bigger than 13.
Oh, but you subtracted.
So that's what I want to. Does that make sense? Where did you? Yeah. So 3 plus 10 is 13. That's why it has to be bigger. Did I answer your question? Or are you good? All right. We feel okay with that? So letter B is where it got goofy because now you have two triangles that you have to do the same thing to. All right.
That's Eugene.
Eugene's still out hiding. Oh, he came back. We found him.
Hey.
Where'd you hide?
The point of the game is to stay.
The point of
What?
The point of the game is to stay hidden until we find you.
I mean, you didn't come looking after me. How do you know?
We went the other way.
So
Eugene knows
Can I hide?
mistakes.
Can I please hide?
So we used to play. Yeah, I grew up in a swimming pool. I mean, Arizona just. Seriously, I did. I grew up in a swimming pool as a kid. During the summer, your attire of your clothing was the swimsuit that you wore yesterday that you hung in the bathroom and it dried. That was what you wore every day. Because you'd go over to your friend's house, what'd you do? You'd go to the pool. Go back to your house, what'd you do? Go in the pool. The reason they did that in Arizona is Arizona's infrastructure for the utility lines wasn't strong enough for the demands of the electricity to go to the houses. So if everyone was running their air conditioning at the same time, it wouldn't be effective because you couldn't draw enough power through the power grid. So Salt River Project, who is the power company in Arizona, convinced the state government to give a tax break to anybody who got a swimming pool. And it was a big tax break. And so in the 70s, everyone got a swimming pool because basically a $10,000 pool at the time, which now would cost you about $30,000 or $40,000. So a $10,000 pool back in the 1970s terms only cost you about $1,100 or $1,200. Okay, yeah, it was unbelievable. So everybody had a swimming pool, and you had a swimming pool because one, at about 10 o'clock in the morning, there would only be a handful of things that could work in your house. So you would have to turn everything off, except for your refrigerator. You wanted to keep on, and usually one fan. You couldn't have 4 TVs on, 6 fans, air conditioning, because the power, you only got half the power to your house. That's how bad it was. So you literally, at about 10 o'clock in the morning, you'd hear, ooh. That meant the air conditioner just turned off because there wasn't enough power on the power grid. So in order to save the power grid and not flip circuit breakers throughout the whole city, they just put half the power out there. So then you got the pool. So we used to play this game. We used to play every pool game you could imagine. Plus, we used to jump off the roof into the pool, and then we got the genius idea of riding our bicycles off of the roof into the pool. And then, as a kid, discovery learning works really well. Usually when your friend gets maimed, that's when you create different rules so no one else gets maimed like them. The first time we rode the bikes out to the pool, Steve Zabinski did, and his feet came off the pedals.
What a name.
And I'll just say that the bike hit him in a place that... So then we made up a rule. Okay, Steve's over there, laying down sideways, crying, which is always funny when your friend starts crying. But it's like, okay, new rule. If you ride your bike off, make sure your feet stay on the pedal. And until some other catastrophic event takes place, then you make up another rule. And that's basically how society developed rules because somebody got maimed by something. That's the
What is the name?
worst thing that happened.
You missed the pool.
Matt, no, well, Chris Massey, when we were 7, missed the pool.
Oh.
Well, he 98% of his body made it except for his cheek, and he ripped his cheek all the way back.
Oh,
Dude.
dude.
That's too much.
This high.
Was it like
Eddie Forsey had a 2-story house, so we really used to go off the 2. That was great. But it was a single-story house. But Chris Massey, I grew up on a street called East Yale Drive. So the greatest Yale Drive lie that existed until we were age 21 was Chris Massey jumping off the roof, smacking his cheek on the side of Matt's pool and ripping his cheek all the way back and having to get plastic surgery. This lasted from like age 7 to 21. And then we felt it was, once we were 21, it was at Christmas time, and we all decided to tell our families when we were all together at this big Christmas celebration. Remember when Chris ripped the side of his cheek open? They're like, yeah. Well, we weren't filling water balloons up in the pool because we used to have these whips that used to go around that used to, push the dirt around the pool. We used to fill up water balloons. You can fill water balloons up huge when you're in the pool. We said that his hand slipped and he smacked his cheek. Because if your parents tell you, don't do that, somebody's going to get hurt, and somebody gets hurt, that it has to be a null and void. You can't say that anymore. So that's
And then you told them
huh?
the truth.
Yeah, we told him the truth. We're like, are you kidding? And then it became that he could have died, and it's like, but he didn't. And then the sad thing is, the real sad thing, and I don't mean to be morbid, when Chris was 22, he had a massive heart attack and died. So,
wait, actually?
yeah, he really did.
The next
What
year.
the heck?
Yeah, it was bad. It was pretty bad. So, yeah, it was bad. But that was the best Yale Street lie. Yeah, we still talk about that to this day, which is good. All right, let's figure out the rest of this one. Sorry about that. I went off time. And if you guys missed the story, it's still recorded. So let's look at this triangle right here. So x has got to be greater than 10, because 10 plus 5. And then x has also got to be less than 20. Does that work? So that's for that top one. Now let's take the same x down here and figure out x has got to be greater than 2, right? 2, is that right? And x has to be less than what? 30. So let's figure out which region's going to work for us. So it can't. So we have 2, 3, 4, 5, 6, 7, 8, and 9 that aren't going to work in this region, right? So this has got to be our bottom limit. And then we have 29, 28, all the way down to 21 that aren't going to work. So this is our bounded region. That's the only region that can work for our x value. Does that make sense? Can I move on? No? Almost done.
Yeah, like.
Oh, we have time, mister.
Let's go.
All right.
Let's just skip
Um,
the period.
Why can this triangle not take place?
Okay, because the two
5 plus
sides
7
that
is
add
12.
up together won't equal 14.
Yes.
The triangle sides not be added
So
together.
5 plus 7 is less than 14. Therefore, triangle does not exist.
Can we draw a picture to like if they ask us on the test?
So if you went something like this, you had a line segment that happens to be 14 in length.
Yeah.
And then you had a line segment that was 7 in length, and then a line segment that was 5 in length.
Yeah.
That would work, because you could easily show by the segment addition postulate that wouldn't work.
Okay.
I like that. All right. Can I move off that one?
Same process, different numbers. Bam, bam, bam. There we go.
Bam, bam, bam.
It is C.
All right. Yeah, that's it. So 12 plus 14 is less than 30. That won't work. Another thing to look out for here as well is how big would that angle be? I don't know if that'd be 50, right? And that would then mean that the side opposite of the 50 is 12. The side opposite of the 20 is 14. So the side opposite of the 50-degree angle must be greater than the side opposite of the 20-degree angle.
Because it's the larger angle.
Right? Hinge theorem, yeah.
Okay, so does the two sides have to equal like the larger side or can it flip more?
Bigger. It has to be bigger. All right. We got time for Kahoot? I think so. Get your phones out. Get your phones out. You don't have a phone? Tom.
AC, stir up.
Go.
Hey!
Getting them out? Go. Get in there. You got 10, 9, 8, 7, 6, 5, 4, 3. Who else?
I'm trying to join, it's just not loading.
That's user error.
Oh my goodness, Benji.
Anybody else?
You messed me up. I tried-
Anybody else?
I think to hot.
Anybody else?
I'm
No,
trying
wait,
to
wait,
join.
wait, it's loading, it's loading. I accidentally typed it hot.
That's my favorite.
Okay, who's Nima? Wait, one sec. Lucas is joining.
I'm also joining.
Yeah, just hold on.
Hold your horses.
Going down by 10.
Alright, give me a name that I should use.
Ruben.
Okay. Ruben Love Sawyer.
What?
Hold on, time out. It's not loading.
You should make your name Swerve.
Okay, what's the game pin? 10, 64, 67. Connecting. Let's go.
Anybody else?
Wait. Ruben.
Hurry up.
I can't find the heart emoji. Heart.
Just hit Ruben.
Sawyer. Okay, you'll see my boom. You see it?
Everyone good? In 3, 2, 1. Woo!
Eugene, I can't see.
Here we go.
Kahoot.
What can we conclude by definition of median?
Circle.
Goodness,
Circle.
goodness. It's 3.
Circle.
It's just like me. His mind goes every which way. Any more answers? Who's lagging? 3, 2,
Oh man.
1.
Oh man.
Oh
Oh, yeah.
First place.
Okay, conclude by definition of altitude.
Oh, one answer. That's me. It's not off.
In 10, 9, 8, 7, 6,
What place are you
5, 4.
Watch this. First place. What can we conclude?
Uh-oh.
Sawyer, Ruben loves Sawyer. Oh shoot.
Why didn't you go all the way above? It's all the
Hurry up.
Oh shoot.
It's all the above. I told you so.
Hurry up. It's being recorded.
I told you.
Sawyer's gonna.
10,
Ruben's
9,
not gonna love Sawyer
8,
anymore.
7, 6, 5, 4, 3, 2. 1.
You should just skip it.
tried so
I was right. I was right.
Oh, Molly's winning. Here we go. Keep going. Good. This is review. Johnny, put your backpack down. We're not lying by the door. We're not.
Yellow and Lois.
It doesn't even matter. One thing I don't know
We
why.
done?
It doesn't even matter how hard
I'm in
Here we go. Look, he's get away from the door. We do not line up by the door. Everybody take your seats now. Unless you're
Yes,
standing at
sir.
your desk. Johnny, I don't know what you're doing, but this is not. Yeah, I understand. We're trying to review for a test.
Okay.
Jeez.
Johnny, sit down.
Give the triangle DEF where DE is greater than. Oh, this is over.
Wow.
Oh no, no.
No, Sawyer. Ruben's love for Sawyer.
We can do this.
I'll answer in my heart.
And again, these are all being recorded, so if you need to watch this later, you can hear all of our shenanigans.
Dynamics.
This is
Dynamic.
It's
30
It's
blue one.
You know what?
It's the side.
It's the hexagon. It's the hexagon. Skip.
Almost there.
It's not a hexagon.
Hexagon.
Blue.
It's the
Yellow.
Hey, Lois.
Whoever wins this gets 1,000 points extra credit. Up.
Lois.
So I'll have the rest of this recorded.
Mr. Strap, can I show you? Can I turn in 5.3 on Monday so I can study from it?
Absolutely.
Thank you.
I just want to get through all these reviews. They're all going to be there.
Thank you.
See you guys. Have a great day. Make sure you wave to the camera as you go by. See ya. Yeah. Okay, see ya, everyone.